All right, so we're going to get started with actually what we want to do, which is solving differential equations. So I'm starting with this one, number 16. We're going to find the first four non-zero terms of the solution about x equals 0 for y double prime plus 2y prime plus y equals 0. Now, one of the things I like about this problem is we actually know the general solution. Think about it, right? You can take the characteristic equation. It's got a double root at y or at x equals 1. So that's going to be this answer. Okay. So let's go ahead and work out the Taylor series solution. Okay. So what we're going to do, we're going to assume that we know y sub 0 and y prime is 0. I'll show you guys why I'm going to call this A0. That's actually going to be A1. Okay, so let's see. Let's take our Taylor series. So we have y of x equals the sum. N goes from 0 to infinity. A sub n x to the n. And if you think about it, right, if you look at it really quick, y of 0, all of these except for the n equals 1, the only term we're going to get back is the n equals 1 term, right? Okay, so that's why I say y of 0 is a sub 0. Similarly, let's take the derivative. Y prime of x equals sum, n goes from 0 to infinity, n a sub n x to the n minus 1. So now, the n equals 0 term, that's 0 too, right? But the n equals 1 term is going to be 1 times a sub 1 x to 0. So that's how you get y prime of 0 is a sub 1. Okay? Now we're actually going to rewrite this. And we're going to get good at it, but I think I'm getting better at it. Let me show you what I'm going to do. I don't like that these are not on equal footing. I want them to be on equal footing. So I'm going to want to write that as something x to the n. So that means I'm going to have this is going to have to start at n equals 0. Okay, that's fine. And now what I'm going to say is this, I'm going to look, what is my first term? If n equals 0, this is 0, but my first non-zero term is when n equals 1. And that's going to give me n to the x to the 0 here, right? So when n equals 1, that means this is 1, and this is a sub 1. So I'm going to need, instead, I'm going to write this as n plus 1 a sub 1. And I just match it. I just check that it matches. When n equals 0, I get 1 here, and a sub 1, and x to the 0. And it matches here. And once I match it at n equals 0, then it's going to match everywhere else. Okay? We'll do that a lot. Don't worry. We'll practice that. Y double prime of x. I'm just going to do it from here. By here, I mean here. So that's going to be sum. N goes from 0 to infinity. N minus 1 times n, a sub n, x to the n minus 2. Okay, now that equals. Still going to go from 0 to infinity. Okay, I still want to have the same power, so x to the n I'm going to write. But now I have to think again. What is my n equals, what is my first non-zero term? First non-zero term comes when n equals 2, right? When n equals 1, this is 0. When n equals 0, this is 0. So n equals 2 is my first non-zero term. So that means this is going to have to be 1, and that's going to have to be 2. So I'm going to, instead of n minus 1 and n, I'm going to write n plus 1, n plus 2, and then my a, first non-zero term, is going to be a sub 2. So I'm going to write a sub n plus 2. Okay, so this is y prime, this is y double prime. Okay, now let's get to solving the differential equation. These things you're going to be doing all the time. Okay, everyone that's second order, you're going to be doing that exact thing. Okay, so differential equation is going to be sum n goes from 0 to infinity. Y double prime is this n plus 1, n plus 2, a sub n plus 2. Now, I'm not going to keep the x to the end because I'm going to put that on the end. I'm going to write minus 2 y prime, n plus 1, a sub 1, plus the y, a sub n, and then they all get the x to the n equals 0. Okay, so this is representing the y double prime, minus 2 y prime, plus y equals 0. Okay, now each term should equal 0 then. Okay, so I'm going to get, and I'm going to take this equals 0. Okay, so I'm going to write that, and I'm going to solve for a sub n plus 2. A sub n plus 2 equals 1 over n plus 1, n plus 2, times, let's see, that's going to be 2n plus 1 a1 minus, I'm sorry, that should be n plus 1 there. Ah. Okay, why did I write that there? Oh, it should have been n plus 1. Okay, we're all fixed now. Okay, so now, this is our recursion relation. It gives us the next term in the power series, or the next coefficient of the power series, in terms of the previous two. Okay, so let's start writing out some terms. So we know a sub 0, a sub 1 are given by the initial conditions. Okay, the next one is a sub 2. Now I like to write out what is my n, just so that it helps me remember what I'm doing or keep track. So n equals, and I did it wrong. A sub 2 is, of course, n equals 0. So that's going to equal 1 over 2, okay, times 2 a sub 1 minus a sub 0. That's going to be a sub 1 minus 1/2 a sub 0. Okay, so that's a sub 2. Okay, let's do a sub 3. A sub 3 is, of course, Now n equals 1. Just following the recursion. So 1 over, that's going to be what? 2, 3, 6. 2 times 2 is 4. A sub 2 minus a sub 1. That's 2/3 a sub 2 minus 1/6 a sub 1. But now, a sub 2, I have it here, right? So I'm going to replace that. So that's going to be, no more space there, 2/3 a sub 1 minus 1/2 a sub 0 minus 1/6 a sub 1. So now, let's combine these. 2/3 minus 1/6 is 3/6, so that's 1/2. 1/2 a sub 1 minus 1/2 a sub 0. Okay, so that's a sub 3. Okay, it asks for the first 4 non-zero terms, so I think that's going to give us enough. Let's go ahead and write it down. So, our solution, y of x, is going to be, now I'm going to actually split it up into a0 and a1 terms. So I've got a0 gets a 1, okay? Now, let me actually write it out first. We'll write it out first, and then I'll show you guys. And then next one, I'll start playing the games, okay? So a0 plus a1x plus a2x squared plus a3x cubed. And I could keep going, but I'm not. Now let's go ahead and plug those in. So a0 plus a2 has, of course, negative 1/2 a0. So I'm going to write minus 1/2 a0 x squared. A3 has minus 1/2 a0 as well. Plus, now, a1 x, right? A2 has an a1 as well, right? A2 has, after we put it together, well, it just has a1. Sorry, a3. Yeah, no, it has just the 1, so it has plus a1x squared. A3 has 1/2 a1. Okay, so this is our solution. Okay, I'm maybe a little curious how it matches up with this in terms of the Taylor series, but we'll let it go for now. Yeah, we'll just have to let it go for now. Okay, all right, I'll see you all in the next video.